All right, today we're doing a few days of the unit circle combined into one. So the first page is an opener. The whole first slide is an opener. Please pause the video, fill that whole thing out. It should take you a few minutes, and come back when you are done to see the answers. All right, here's what you should have got for all of the answers to the first slide. If you need to take a look at that in detail, pause the video to look at it. Otherwise, we're going to move on to the second slide. All right, our first example of the day here, given the following information, find the exact value of any remaining trig values not given. Be sure to draw your triangle in the correct quadrant. That is key to this. Quick note there, the hypotenuse, no matter what, the hypotenuse is always positive. So whether your x value is positive or your y value is positive, or your x value is negative, your y value is negative, the hypotenuse is always positive. All right. So first problem here. We see sine is 1/2, cosine is √3/2. Remember that the sine is the y value. So our y is positive and cosine is x value, so our x is positive. What quadrant are both x and y positive? Well, that's the first quadrant. So draw a triangle in the first quadrant. A right triangle in the first quadrant. When you draw a triangle, always draw it to connect to the x-axis, not the y-axis. And always put theta near the origin. So now it says the sine is 1/2. So sine is opposite over hypotenuse. Cosine is √3/2. Cosine is adjacent over hypotenuse. We already have the 2 there. All the work is pretty much done for us already. Okay? Now our job is just to find the remaining 4 functions. It doesn't have to be in any order. The tangent is 1/√3, or if you rationalize it, √3/3. The secant is the reciprocal of cosine, so 2/√3, or if you rationalize it, 2√3/3. The cosecant is the reciprocal of the sine, so that's just 2. And the cotangent is the reciprocal of tangent, so that's √3. And that's it for the first problem. Problem B, the sine is 1/3, so remember that means y is positive. But actually this pretty much tells you what quadrant to draw it in. Think about your coordinate plane. What coordinate plane lies between pi/2 and pi? That would be the second quadrant. So draw your triangle in the second quadrant. Put theta near the origin. Sine is opposite over hypotenuse. So for this one, the third side here, this is our x-coordinate. We don't know it. We can do Pythagorean theorem. And we get x squared plus 1 equals 9. So x squared equals 8. So then x must equal either plus or minus √8, which reduces to plus or minus 2√2. So how do you know if it's plus or minus? We are in the second quadrant. Is x positive or negative in the second quadrant? X is negative, so this is negative 2√2. All right, so now we got to find our other 5 answers here. Maybe start with cosecant, since this is the reciprocal of sine. So that's just 3. All right, cosine is adjacent over hypotenuse. Secant is the reciprocal of that, so it'd be 3 over negative 2√2. And if you rationalize that, negative 3√2 over 4. tangent is 1 over negative 2 root 2. And if you rationalize that, negative root 2 over 4. And cotangent is just the reciprocal of that, so negative 2 root 2 over 1, or just negative 2 root 2. And that's it for B. Question C says the sine is 1 over root 5. So that's telling you that y is positive, but x is negative. So what quadrant are we in this time? We are in quadrant 2. The sine is opposite over hypotenuse. Pythagorean theorem here. So again, this is our x-coordinate. So x squared plus 1 squared equals root 5 squared. Remember, root 5 squared is just 5. So x equals positive or negative 2. Again, since we're in the second quadrant, x is negative. Okay, now we can answer our questions here. So let's start with cosecant. Since it's just the reciprocal of the sine, that would be root 5. Cosine is negative 2 over root 5, or rationalized to negative 2 root 5 over 5. Secant is the reciprocal of that, so negative root 5 over 2. Tangent is negative 1 over 2. And then cotangent is negative 2 over 1, or just negative 2. So I'm going to have you try problem D. You can pause the video here and come back when you are done. Here are your answers for question D. All right, the next slide is just a blank unit circle. You can see Schoology for a key to that, or you can just simply search for a filled out unit circle. And you can use that to help guide you on this last slide. Now, you shouldn't need to have the unit circle in front of you while taking an exam. Okay, you should be able to do this all from prior knowledge. Remember that sine is y, cosine is x, and then the other 4 you can do by some combination of x and y, whether it's just a reciprocal or x divided by y or y divided by x. All right? So sine of 60. Sine of 60 is the y-coordinate of the 60. That's just simple root 3 over 2. Cosine of 120, that's the x-coordinate of the 120. So you think of it as a 60-degree reference angle in the second quadrant, negative 1/2. Cosine 7 pi over 6, that's a 30-degree reference angle in the third quadrant. So it'd be negative root 3 over 2. Tangent of 30, tangent sine over cosine. So 30 is 1/2 divided by root 3 over 2, which simplifies down to 1 over root 3, which rationalizes to root 3 over 3. Tangent of 150, that's another 30-degree angle. So it's the same answer, except we're in the second quadrant. So this is going to be negative root 3 over 3. Cosine 300. 300 is a 60-degree angle. The cosine is the x-coordinate, so that'd just be positive 1/2. We're in the fourth quadrant there. Tangent 225, it's a 45-degree reference angle, the third quadrant. Tangents of all the 45s is 1 or negative 1. Third quadrant, it is just 1. Sine of 450, if we subtract 360 from that, we get sine 90. So this is basically asking what's the sine of 90. The y-coordinate of 90 is 1. Sine 240, the y-coordinate of 240, that's a 60-degree angle in the third quadrant. Negative root 3 over 2. Cosecant pi over 3, that's a 60-degree angle in the first quadrant. Cosecant is the reciprocal of the sine. Sine is root 3 over 2, so cosecant is 2 over root 3, rationalized to 2 root 3 over 3. Secant 3 pi over 2, that's the reciprocal of cosine. The cosine of 3 pi over 2 is 0, so this is 1 over 0, which is, of course, undefined. Secant of pi, the reciprocal of cosine. Cosine is negative 1. 1 over negative 1 is also negative 1. Cosine 7 pi over 6, that is a 30 degree in the third quadrant. The x-coordinate for that should be negative root 3 over 2. Cotangent 11 pi over 6. So cotangent is cosine over sine, or x over y. 11 pi over 6 is a third degree in the fourth quadrant. So this would be root 3 over 2 over negative 1/2, which simplifies to negative root 3. Tangent 3 pi over 2. Tangent is sine over cosine. So sine over cosine, and again, that would be undefined. Cotangent 5 pi over 3. That's a 60 degree in the fourth quadrant. Cotangent is cosine over sine. So cosine over sine reduces to negative 1 over root 3 and rationalizes to negative root 3 over 3. Secant 4 pi over 3, that's a 60 degree in the third quadrant. Secant is the reciprocal of cosine. The cosine is negative 1/2, so this is just negative 2. And finally, secant 315. 315 is a 45 degree in the fourth quadrant. Secant is the reciprocal of cosine. The cosine is root 2 over 2, so this is 2 over root 2, which rationalizes to root 2. And there you have it for section 4.3.